Hi, my name is Larry Socher. I'm responsible for Accenture's network practice for communication service providers. Basically any work that we do around the globe with communications clients and helping them build out new products and services, new network infrastructure, and then a lot of the operational capabilities, everything around planning, service provisioning, and service management for those new products and services. Looking at the mobile world right now, I think the biggest issues that face wireless operators are this whole proliferation of all these smartphones. So you start to get the iPhone, the BlackBerry and RIM's latest releases, Windows 7 coming out, all of a sudden Android obviously, all of a sudden we have some very powerful devices and the applications are starting to proliferate. So all these new applications are driving a tremendous amount of traffic on these networks. So now to date, we've obviously focused a lot on radio access, so 3 and 4G deployments. The real next problem that we're starting to face is the backhaul and how we get that traffic back to the internet. So you've got all these really exciting new applications coming out, stuff like Google Goggles, very innovative apps, but they're really starting to chew up bandwidth. And once we solve the radio access network, we're having quite a bit of trouble on the backhaul side. So I actually find a lot of time we're spending now is working with a combination of wireless operators on how they do their cell site backhaul, moving over to Ethernet and IP, and then actually working a lot with the wholesalers who are providing those metro Ethernet connections for those wireless operators. Well, what we're seeing, we're just, even when you start to upgrade to 3G technologies on the radio access side, we're starting to see that the traditional T1 or E1 infrastructure, it just isn't handling the amount of traffic that we're seeing. So you see the iPhone, for example, when it goes out, a lot of these applications are very chatty. Use the network pretty heavily, and the existing T1 and E1 circuits just aren't capable of handling that backhaul. So it's a big push initially through microwave, but now rolling fiber more to the cell sites. So really trying to move out there quickly, and I think there's quite a bit of a burning platform because those applications are taking off very quickly. Smartphones obviously are proliferating very quickly in the market, so we're finding it's quite a bit of stress on the backhaul and transport networks. We're facing quite a bit of challenges around just the applications that are proliferating on the iPhone, Android, BlackBerry, and obviously those apps have taken off, and we're really starting to see quite a bit of internet usage going up. The interesting thing that I've seen, I see a lot of slides in Accenture, obviously, but one of the most interesting ones I saw was one of our media entertainment guys, Robin Murdoch, showed me the slide, and he basically looked at all of the music ever made, and these are rough numbers, but we think that's about a little over about 1.5 petabytes. You then look at all the movies, production movies that are ever produced, and we think that's somewhere in the range of, let's say, 4 to 5 petabytes. You now take a look at 1 year of television content in the United States, and we think that's around anywhere from 12 to 15 petabytes. And what's interesting is our networks, our content delivery networks, the asymmetric nature, very download-centric, are focused on those type applications where I'm uploading once and we're downloading multiple times. If you now shift over to user-generated content, and if you look at the average daily uploads of just photographs in the United States, we estimate that to be somewhere in the order of magnitude of 40 to 45 petabytes. And that's just 1 day of content. And what's different here is if you look at that, that is going to very different usage of our networks. We're looking at now one upload, and for the most part, most of that content's not viral. I'm uploading it to Facebook, to Shutterfly, to YouTube, and for most of those things, there's maybe only 5 or 6 downloads. So you've got a very different ratio for the majority of that content. So all of a sudden these networks, and order of magnitude significantly more than all of this professionally produced content. So all of a sudden we've engineered everything for download, we've got our CDNs to support that, and we have a huge upload problem. And to exacerbate that, it's basically the mobile devices that are going to be the point of capture, and the user is going to want to take that picture and upload it immediately. Now to make things even worse, videos started to take off. So not only do we have these increasing number of megapixels in these cameras, but we're about to get to an environment where we're going to have high-def video on our mobile phones, and we want to upload while the content's hot. So these networks that we've deployed deployed for high-speed download, we're worried about video distribution out, the upload is going to be an interesting problem. And we're really going to have to relook at how we engineer our networks. It's interesting. I mean, clearly backhaul, which we're already seeing with some of our applications, but here I actually think when you look at the radio neck, where the asymmetric nature, it's very much being optimized, for higher download speeds, slower upload. So actually thinking, how do you get more balance in the upload to handle that traffic? Increasingly too, I think a lot of the digital cameras, the video cameras will start to have mobile capabilities built in. So as we start to see the embedded communications, connected devices proliferate, it's going to become even a bigger deal. So I really think the whole the radio access networks engineered, the amount of upload versus download will change significantly as user-generated content continues to proliferate.